Welcome to our video simulation series. This is round one in which we look at the impact of the unit cost equation on manufacturing system design. We have three other rounds in which we'll look at the progression of design thinking in development of the simulation of a manufacturing system with Legos. I'd like to thank Joe Smith for his work in developing this video series, and also students in the Systems Engineering Lab, Sarah Smith, Ankar Sunar, and Shahab Shah. So this is an illustration of the part that we're manufacturing. It consists of two large Legos and two small Legos. We intentionally made the part simple to illustrate the complexity that the manufacturing system has during operations. Here you see the desired output of the simulation. We would like to produce 8 red, 8 green, and 8 blue Lego products in a representative 8-hour shift of 3 minutes 12 seconds. We are also going to simulate what happens when the system produces defects. Here you see possible types of defects where the yellow Legos represent an incoming defect from the supplier. The incoming parts from the supplier were dictated by the purchasing department, so manufacturing had no impact on how the containers were configured. Purchasing basically said that we would put large Legos in these bins containing 6 parts, and also the small Legos would be in the small bin containing 6 parts. The way we're simulating defects is to add 1 yellow on average to each of the bins. The supplier ships the parts, and we're representing that supply time to be a 30-second round trip time. 15 seconds from the supplier to assembly, and then 15 seconds back from assembly to the supplier. Please observe in this simulation the impact of the unit cost equation on production. The unit cost equation has the thinking that the more product we produce, the lower the cost. It doesn't emphasize making the right product, the product that the customer wants. It doesn't emphasize standard work. It doesn't focus on improving ergonomics. It doesn't look at improving quality. Also, it doesn't look at linking communications between operations, since we're really focused on the cost of the single operation as standalone. Finally, and most importantly, defects are shipped to the customer. This graphic illustrates the unit cost equation. It is focused on the unit cost of an individual operation, or piece part cost, dollars per unit, of a single operation in the factory. So for example, an operation would be assembly or fabrication. So it's the sum of the direct labor of the operation plus materials plus overhead allocated to that operation divided by the number of units produced. The overhead allocation is the direct labor time of that operation divided by the total direct labor time in a plant times the overhead pool of cost. Typically, overhead is allocated based on direct labor time in this manner. Notice that the consequence of the unit cost equation is to reduce direct labor by reducing the number of workers, sourcing lower labor wages, replacing people with automation. Also, the goal is to minimize the number of changeovers, which is called the run size, the number of units we produce of the same type before changing over. We try to make products as fast as possible, not balanced to the customer's demand pace. And we even look at sacrificing material costs in terms of quality. Ankar will serve as our supplier, while Shahab is managing green assembly, Joe is doing the blue Lego assembly, and Sarah is doing red Lego assembly. Shahab is also serving as our on-the-job trainer. Here's the physical layout, where Ankar is on the left at the supplier table, and we have 3 assemblers at the assembly table feeding the customer of their work, which is the shipping table.
3, 2, 1, go. I don't know what my job is.
Your job is to take them the way I'm taking. Just sit on them.
So it's just 2 of these and 2 of these.
No, not from this way. The small Legos can go in between, and then the big Legos on top. That's how the customer wants it. Just don't have the new idea. Okay? Learn the job first, then start coaching.
Produced a lot more than me already.
Because everyone looks at black man. Go ahead, go supply it.
You remember?
Right there, the ticket so they can do the inspection. It happens all the time, man.
Two shoes over here. They're all neat and organized. Wasting time over here.
So don't damage the safety of the product actually. The product is supposed to go this way, not this way. Put it this way.
Are we done?
Yeah.
Take a few minutes to reflect on what you observed from the round 1 simulation and write down your observations. Next, we ask the question, was the customer demand met? And what did the system actually produce in terms of products? So please write down what the actual output from the system was from a product viewpoint. Also, how many of those products were defective? Take a moment to review these key takeaways from the simulation.